started. I have a very loud voice, but I'm getting amplified because we're recording this event for posterity. Welcome, or I should say welcome back. I'm Danilyn Rutherford. I'm the chair of the Department of Anthropology, and I'm really excited to see you all here today. In the department, there's a lot going on. We have new faculty, new students, new courses, new kinds of topics people are working on, secularity, the Anthropocene, molecular anthropology, new threats, new opportunities, all sorts of new things are happening. We have an exciting present. If any of you were able to come to the Undergraduate Research Symposium, you will be able to see some of the fabulous things that our undergraduates are doing. Two of them just won Dean's Awards for their research. So it's a really exciting time to be here at UC Santa Cruz Anthropology. So we have an exciting past, we have an exciting present, but we also have a very exciting past. We have an exciting tradition in this department. And that's one of the reasons, or the main reason, that we're here today. I arrived at UC Santa Cruz 5 years ago, a closet biology major. I'm a cultural anthropologist. And one of the things I was really excited about in coming to join this department was the fact there was a strong, innovative subfield in biological anthropology. I was particularly excited when I became chair and had a chance to get to know Adrienne a little bit better and get to know more about her research. Adrienne, as you all know, is an amazing scientist, an amazing teacher. She's also an amazing person. She's been a real pioneer within the subfield of biological anthropology. And it's been so exciting and inspirational to get to know her and to learn about her work and her career. When Adrienne decided that she was going to retire, we cast around trying to think about what we could do in honor of everything that she's done within her field. Now, I should say her retirement was simply actually a job reclassification because she's been working very hard on her research in the intervening years. But when she decided to reclassify her job, we had to think about what was the right way to mark that moment. And immediately came to mind. Adrienne played, as you'll learn in a few minutes, a foundational role in the design of this building. Okay, and her laboratory has been the site of deep excitement, deep advances within the field. It made complete sense for us to want to name her laboratory in honor of her. This being UC Santa Cruz, however, there are rules. So we were very excited about this 3 years ago, but we've had to wait. There's a certain amount of time that needs to pass between when a faculty member retires and when the actual naming can happen. So we've been waiting for 3 years to hold this party. As you can imagine, we're very excited to have it begin. So I want to start with step one, which is I'd like to invite Adrienne to come up. On behalf of the University of California, Santa Cruz, I'd like to present you with this plaque, which will go on the outside of your laboratory. It says, the Adrienne Zihlman Physical Anthropology Laboratory, named in recognition of Professor Adrienne Zihlman's lasting contributions to anthropology and the study of human evolution. Department chair. So I'm not the person who's going to do the formal introduction. That's Ted Grand, and we're really honored to have him with us virtually. Ted Grand is currently a research associate at the National Zoo, where he's been since 1983. He was formerly a researcher at the Primate Center in Portland. He's acted as visiting professor at the University of Oregon, the University of Colorado, the University of Western Australia, and Central Washington State, where he's taught comparative anatomy of mammals, locomotive mechanism in animals and humans, and courses on the evolutionary process. He also taught human anatomy for several years at the Uniformed Services University of the Health Sciences, which is a military medical school in Bethesda. Ted Grand and Adrienne met at UC Berkeley as graduate students under the guidance of anthropology professor Sherwood Washburn. who was a giant within our field across the subfields. Their early collaborations and network of brilliant mentors provided the foundation for their long-term friendship and their continuing partnership in philosophical discussions and scientific endeavors. Ted's unique dissection procedures for gathering tissue composition data and applying the results to interpret locomotor anatomy inspired Adrian's scientific methodology. These whole body dissection methods have been practiced and honed here in the UC Santa Cruz Anthropology Laboratory.
Good afternoon. I do not have a history of gate crashing events, but there's a first time for everything. I even bought a new shirt. If anyone takes exception to my interruption, please regard Carol, Debbie, and Fred as unindictable co-conspirators. I have known Adrian for so long that it gives the phrase very old friend a special meaning, even if it is indecorous, indiscreet, even ageist when applied to a woman. The fact is, every year on my birthday, she sends me a card and reminds me that I'm still older than she is. Adrian was the prize student of 3 exceptional teachers, Jack Kelso from Berkeley, Herb Shrebnick, and Sherry Washburn from Berkeley. She was the sort of student that a teacher dreams of, not simply intelligent, but endlessly curious and inquiring. As a frosting on their cakes, she remained a loyal friend to each of them. Well, the acorn never drops too far from its oak tree, and she has returned her gratitude to generations of her students. As she came to appreciate the value of hand-eye-brain coordination to learning, she developed her Human Evolution coloring book. This has spread its influence so far beyond Santa Cruz that Henry Adams could certainly have been thinking about her when he said, "A teacher affects eternity. She never knows where her influence stops." As a researcher into human origins, she has never taken her eye off the target, proof that a well-aimed arrow hits the bullseye every time. Along with Doug Kramer and Jack Cronin in a 3-page jewel for nature, they identified the pygmy chimpanzee as especially significant to our ancestry. Excuse me. This single elegant paper synthesized locomotor mechanism, social behavior, the fossil record, and molecular evidence. It shifted the level of focus of all comparative discourse. Speaking of our good friend Doug, Adrian so appreciated her need for artist as anatomist that her collaboration continues with Carol on their book. She and her colleagues have studied and dissected more individuals within the hominoid radiation than anyone ever has or anyone is ever likely to do in the future. By comparison, think of the number of journal pages devoted to a piece of broken pelvis, the fragment of a jaw with a single tooth. It is fitting that this laboratory be dedicated to Adrian, the site that connects her colleagues, generations of students, and the thousands of hours that they've spent here. Finally, I think of Adrian as something of a Ulysses, skillfully navigating the Scylla of academic pettiness and the Charybdis of the old boys network among physical anthropologists. In the language of the astronauts, she had the right stuff. She could never have pulled off what she has in terms of the monumentality of the collection if she had not had the trust and respect of everybody that she had to deal with, the institutions, the varied policies and regulations that covered the great apes and the gibbons. Okay, I'm done. If you want to call campus security. Anyway, good luck, and I wish I could be there in the flesh. Bye-bye.
So, Tess, can everyone hear me? It gives me a minute or two to collect myself, because this is really through the generations, because when Ted and I were graduate students, he was finishing when I just started, and we both connected on anatomy, because we both loved anatomy, and so we would go around campus and find animals to dissect. And I remember one time we got, somebody lent us a formalin beaver in a great big bucket, and they let us use it and sort of take it apart, and especially study all of the muscles that go with the tail, the back muscles that go to the tail. And then I had my father, whose brother has a farm in Iowa. My father would go and spend fall and spring there to help me with the planting. But on the side, he would go and collect gophers and moles, and we gave him instructions that he'd put them in alcohol and send them, and Ted and I would dissect them. So Ted and I are really anatomous under the skin completely. So whoever organized that, thank you guys. I begin by talking about this building, because in 1994, the spring of 1994, we, as anthropologists, the anthropology department, moved into this building. We'd been in Kerr Hall for 15 years, and I think unless you really lived there for very long, you can't imagine. The stairways were narrow, dark, and damp, and we had one room where we did everything. We taught our labs, we prepared skeletons, especially from roadkills that various folks would, where's Diane? But the exciting thing was, for the first time, I had, after being in Santa Cruz for 27 years, I finally had a place to do my anatomical research. Now, before that, so for the previous 27 years, I was sort of shifted around. I remember I was in Nat Sci 2, the roof of Tiemann, got to Kerr Hall, so I had many different labs on this campus in the meantime. And my startup package, when I first took the job here, was a big black table. So I hauled this table around to all of my makeshift labs that I had for those 27 years. So it was really nice to get away from Kerr Hall, where we had to live on top of each other, literally. And that Carol, Cope, and Debbie Bolter, and Rand remember the classes that we had in Kerr Hall. So here we are in a new building. This is part of it. Open stairways, teaching labs, research labs, and of course the new dissection lab. Now, at that time, there was no equipment. It was just nice big room with, of course, the sink and the hoods. But I was able to easily put my black table in there, so we had a very nice surface for dissection. We also had a walk-in freezer, a freight-size elevator, wide hallways. And see, I was preparing for my fantasy silverback male gorilla that I knew one day would come from heaven. Have this special animal. Well, let me say a little bit about my research that got me into all of these critters. Began with my dissertation topic on human locomotion. And so the major question I was addressing is, how do you get a human biped out of a four-legged ape like a chimpanzee? I mean, things obviously happen in evolution for that kind of transformation. So to begin to answer this question, I studied lots of bones, pelvis and leg bones, foot bones of humans and chimpanzees. And I dissected the hip and thigh of humans, monkeys, and apes. I wanted to learn about muscles and joint function. And then I studied fossil bones from East and South Africa of these early humans around 3 to 4 million years ago. Now, most of these bones consisted of lots and lots of teeth and a few cranial, head, skull kinds of bones, and a few pelvic bones, a few arm bones, a few leg bones, and even a couple of little foot bones. And that was about it. Very fragmentary. Now, these early humans that I was studying, Australopithecus, are about the body size of a chimpanzee with a brain size, the size of a chimpanzee, but their pelvis indicated that they were definitely walking on two legs. So we really at that time did not know almost nothing about the muscle system of chimpanzees. Most of the work that's been at that time were a lot of work on the dentition and a lot of work on the craniofacial anatomy. Very few studies on either muscles and nothing on a whole animal. Now, by contrast, we know a lot about human anatomy, but there are problems if you want to go back and try to reconstruct what's happening 3 to 4 million years ago. There are severe limitations by using Homo sapiens to try to work back. What you want is some kind of ape that's closer to those critters that lived 3 or 4 million years ago. So I realized that one of the things that I really needed to do, I couldn't spend my career trying to intensively study these few fragmentary bones to learn about locomotion. And I began to realize that's really only a small part of the whole body. And what we do know about human locomotion is that it's really a whole body activity. So I realized then that what I want to do now is to really start doing work on chimpanzee anatomy to try to fill in some of these gaps and then begin to look at the fossils. Okay, but now here comes the problem. How do you get ape specimens to study, whether it's a chimpanzee, a gorilla, or an orangutan? This is no small task. First of all, apes are rare in captivity. They have very long lives. They have medical care that rival most of the human population in our country today. And the timing becomes extremely critical. And by that I mean when you hear that a great ape is sick, you don't want to seem too eager. You don't want to be an ambulance chaser. But you have to make contact with the appropriate institution, the appropriate curators. You have to do a lot of fast talking. You really have to try to persuade them to give you the whole body. It's called persistence, not being discouraged. Now, most researchers, this was particularly in the 60s and 70s, most researchers who were doing some aspect of primate anatomy wanted a particular part of the anatomy. Either, let's say, the brain, or the hands, or the feet, or the thigh bone, or the thigh area, different pieces of the anatomy. And then you would get on a list, and when an ape died, then they would cut it up and they'd send the pieces out to all the researchers that wanted them. But I didn't want pieces, rhesus or otherwise. I wanted whole animals. Now, the fact that I wanted whole animals was ended up being both a positive and a negative situation. Negative in the sense that they would say, well, these animals are spoken for, we have to give an arm to Stony Brook and we have to give a leg over to Arizona State or whatever. However, on one occasion, I had the opportunity to get a male orangutan named Bubba. He was 24 years old, from the Houston Zoo, and he had died of something like pneumonia. He died very quickly. He was loved by all of the entire zoo, the entire population in Houston. So when I told them that I wanted the whole animal, they were so relieved that they gladly sent me Bubba, because they couldn't face the idea that he was going to be all cut up and sent to different people. So that worked in my favor. So each of our apes has a good story behind it. The point is that the whole process is really unpredictable. I always tried to be tactful and, be a good scientist. Although I have to confess that once I did resort to hysterics and tears when animals that were promised to me were threatened to be given away. And that kind of put me over. But most of the time, I've been very professional about this. So in the late 1960s and early 70s, I began doing a lot of dissections on chimpanzees, working with other colleagues at other institutions. And one of my major dissection partner was Linda. Where are you? Linda Lebret. She was a graduate student at Berkeley at the time, and we both realized our passion for anatomy. We went to Harvard once and dissected Edgar. We went to the University of Arizona for untold numbers of chimps. We went to Arizona State and Phoenix. We went to the Oregon Primate Center. So wherever there were animals, Linda and I were there. But in around 1976, I started getting animals sent here to Kerr Hall, to UCSC. And so didn't travel as much after that. And I remember the first adult females that we dissected, and this was the first time that we applied Ted Grand's methods, where you, and I'll say a little bit about that in a minute, but a very specific way of collecting the data. And Karen Wislow, who is, where's Karen? Organized the team. We got together a team with Linda, of course, and several UC students. And it was really quite an event because we had a lot of learning to do in taking this animal apart. So you can see that there's no way that my students ever really got away from this. I just have to tell you what Linda's nickname was. She's such an incredible dissector that we called her the fastest scalpel in the West. So what do we do in our dissections? What is the Ted Grand method about? What we do is we have a very specific protocol of how you take the animal apart. And once you start taking it apart into pieces, which is important, because you can't do this all in one day, so you have to keep some of the material frozen. After you take it apart, then you systematically separate the skin, the muscle, the bone, the fat, connective tissue, and you weigh everything. So it's a quantitative method as opposed to being strictly descriptive. And it takes into account the whole animal rather than just parts. So obviously you're studying the parts, but it's the parts to the whole. So once you get all of this quantitative information on one individual, you can start to construct a profile of that individual. So for example, you can determine its body composition. In other words, how much body mass is in the arms, how much in the legs, the hands, the feet. You can pick anything you want to know about. And just to give you an example, skin, our skin is about 6% of our body weight. In chimpanzees, it's more like 12 or 13%, so it's about twice. And you can do that then with all of the different tissues. You can also determine body proportions. How much body mass goes to the arms, how much to the legs, how much to the head, the trunk, whatever. So for example, our arms, human arms, are approximately 8% of our body weight. But chimpanzees and gorillas their upper arms are somewhere between 16 and 19% of their body weight. So they're partly strong because they've got all that mass in their upper limbs. Or, for example, a third thing that you can do is to determine where muscle is distributed. So you take all the muscle that you've taken off the animal, which equals 100%, and then you see where it is distributed in the body. So, for example, between 55 and 60% of our muscle as humans is in our hip and lower limb. For chimpanzees and gorillas, that's only 45%. So you can see then, you can start making the connections between anatomy and locomotor behavior. And because you've collected your data in a systematic way, it means that you can now compare not only your data, but people who use the same methods. And so you really can have a big database as a result of this. You can document how males and females differ. You can document how infants and adults. Just to give you another example, in terms of body composition, an infant chimpanzee is only 22% muscle. As it grows up, becomes independent in terms of locomotion, that goes up to 40 to 50%. So you can track through growth and development exactly how the body is reorganizing in terms of body composition, body proportions. And that's really fun. Well, quite by accident, I got involved in studying gorillas. I mean, my thing was chimps and chimps and chimps. But I was on sabbatical for a year in the early 1980s, and Linda McGrath came to UC and taught my classes. And she was also, we were also still continuing doing our anatomy. So while at UCSC, she got the word that a female gorilla named Mrs. died at the San Francisco Zoo. Linda was on it. She was in San Francisco faster than you can say San Francisco. She somehow managed to get permission for this body, and before anyone could change their mind, she stuffed it into the trunk of her car. So that's another story that I don't have time to tell too much, but as I said, every ape has a story. Now, the dissection was a real happening. I mean, we had Kerr Hall absolutely packed, and Carol and Rand were there. Catherine, where's Catherine? Catherine was there. We were taking this animal apart very quickly and had a lot of helpers. It was really quite something. So, and a couple of years later, I got a call from the Fort Worth, Texas Zoo. See, word gets around. And she said, we have an old female gorilla, and I think because she was so old and she was a little overweight, that nobody really wanted her for research, but they said, would you like to have, and her name was Sue. So, how can I turn down a gorilla? So at this point though, I went to my chairman and I said, you know, I need the biggest possible freezer that you can buy because I'm getting this very large gorilla and I need to keep it frozen until I can really take it apart. And I had wonderful support from the chairman, the social science division, and the faculty research, even for long, to have a big silverback male gorilla that is twice the size of the females. What would we find? How might that be different? Well, fortunately, just exactly at this time, I was put on the building committee for colleges 9 and 10. They were to be devoted to the social sciences, and the facilities were to accommodate research, teaching labs, classrooms, administration, classes with labs, research needs. So my job was to represent the curriculum. So I would talk to the committee about, specifically about our research needs in osteology and archaeology, and of course in the anatomy lab. And that was really what I was really supposed to be doing. However, I had a few opinions about some other things. One of them was, I really argued for the large open stairways that we have. And I emphasized, I was explaining to these people, as a social scientist, the importance of these kinds of spaces. So people meet going up and down the stairs and can talk to each other face to face, the primate way. Well, once the the anatomy lab was on the books, but thinking about my fantasy silverback, I thought we might need a few other things for when that comes down from heaven. So we would need a walk-in freezer. So they were very accommodating. Oh yeah, we think we can fit the walk-in freezer right there. Fine. But we also need a freight-size elevator, you know? These animals weigh hundreds of pounds. So that seemed to work out okay. And of course we need wide hallways because if we're going to have to take it from the elevator down the hall, we got to have it wide enough. So yeah, they went along with it all. And sure enough, when we moved in the spring of 1994, we were all so excited. I remember taking pictures of Judith. Remember Judith? And holding up and touching the room number for your new lab. So we were all really thrilled. So the summer came and went, we unpacked, we settled in for the new academic year in our new quarters. Before long, it was Labor Day weekend. The planets were perfectly aligned because on Friday night, I got a telephone call from a colleague at San Jose State, Bob Germain. And he said, Juana, the silverback gorilla at the San Francisco Zoo, was very ill and was not expected to live. And he thought I might be interested too. So Saturday morning, by this time it was kind of late in the evening, so on Saturday morning, really early, I started calling the zoo. Didn't get answers, left messages, kept calling. Finally, I made contact with the zoo veterinarian, Freeland Dunker. And it turns out that Juana had died, and in fact, they were just finishing the necropsy. So I explained my research and begged for Juana. I think that Freeland didn't quite know what to do about that, but he was very accommodating. So he said, well, you know, Juana is supposed to go to the California Academy of Sciences. And I said, well, I'm a fellow and a science trustee of the Academy. So I can guarantee you that that skeleton will end up at the Cal Academy. So he was happy about that. So just to tell you a little bit about Juana, because it's been a long time, but he came to San Francisco in 1960 when he was just a little tiny gorilla. And and I came in 1962, and all of the trips I made to the San Francisco Zoo, I followed Juana as he grew up. He sired several offspring, including Coco, of sign language fame, his sons, Sunshine, who was sent off to Chicago, and Kubi, who ended up being the alpha gorilla as Juana got older. In 1980, the gorillas were moved into their new outdoor facilities, but before that, they had to knock them down to move them. They had to move them quite a distance up through the zoo. They underwent a thorough medical exam, and there was this assembly line that started with the veterinarians, then there was the dentist, then there was us anthropologists, and we got to measure him, take hand and footprints, and Linda was in on that too. So there we were with our equipment measuring these gorillas. We measured Juana, Mrs., Kubi, and all the others. So we actually knew these animals before they died. We actually had experience with them. And they were very well anesthetized as we were manipulating them. So it was really sad to think of Juana. Take it easy, don't break any legs. It was very sad to think of Juana no longer being there, but he was not forgotten because he was eulogized by Herb Cain, who was very famous. Mr. San Francisco had a daily column in the San Francisco Chronicle. So Juana was gone but not forgotten. Well, I was very eager to get Juana before anybody changed their mind. So Jerry and I headed out to the zoo. Just as we pulled into the parking lot, Ray Bandar arrived with his knives and equipment, and he was ready to get to work. Ray prepares animal skulls, animal skeletons for the collections at the California Academy of Sciences. And he first removes all the flesh. Now, for those of you who were in San Francisco last year and saw the skulls exhibit at the Academy, one wall is devoted to the sea lion skulls, that Ray had collected and prepared over a period of decades. And they're actually now on a different wall, but they're still at the Academy. So I explained to Ray that I wanted to study the flesh on the bones, and that I would see to it that the skeleton did go to the Academy, and I reminded him of how much work that would save him, that I would take off the flesh. He wouldn't have to do that. Well, we had driven my Honda Accord out to the zoo, and I thought maybe we could get Buana into the trunk. Or tie him to the roof. I mean, Linda did it with Mrs., so I thought, this might work for Buana. Well, when we saw Buana, that was not going to work. He's 380 pounds and stretched out was 6 feet long. So what to do? Well, I thought of Robin. Robin's husband, Jeff Barlier, is a contractor and has a pickup truck. What could be more perfect? Now, Robin had to do a little persuading, but Jeff did reluctantly agree that we could use his pickup truck as long as we cleaned it up after. So the next morning, Robin and Jeff, along with their 9-month-old son, Reed, the whole family came. And it was really quite a project to load him in. We backed up the pickup as close as we could to where the autopsy had taken place, and we all were heaving and pulling and finally get him into the truck. And then we all headed to Santa Cruz. Now, just one little twist, you know, there's always these little things. When we got to Santa Cruz, it turns out there was a bicycle race that was going through the campus. So there were a lot of roadblocks, and we had to kind of maneuver around to finally get to social sciences. Well, now we had the next challenge, and that was to get Buana into the 4th floor freezer. Now, we had no proper equipment at this time. So this is, you know, when they talk about how manipulative we are as a species and problem solvers. Well, someone managed to find a piece of plywood that was maybe about this wide and about half this length. And then we happened to find, we scrounged around looking, and we found a little cart, you know, the kind that in the restaurants come around and you pick your dessert or you know, this little. So we took the plywood, we put it on the little cart, and then everybody got pressed into service in hauling him from Jeff's truck over onto this little shaky. And remember, we had Fred the librarian and Bill the computer guy and the maintenance guy who had taken out the barrier so we could get in, and Jerry, and we were all helping, heaving. And I was thinking, thank God for that elevator, because just one plus all the people trying to keep them steady, we could never have done it in a smaller elevator. So we did manage. We were breathing great sighs of relief when we got him in the freezer. So for the dissection, we had quite a team. Robin, Linda, the Faithfuls, several UC students, and John Gurchie. John Gurchie is an artist, painter, and sculptor who's known for his illustrations in National Geographic of dinosaurs, but particularly of early human fossils. So you probably, if you read National Geographic, I'm sure you've seen some of his work. So for about 10 years, John had been coming to Santa Cruz, and I would share my animals with him because he was really interested in the details of facial anatomy and would take lots of measurements and very carefully separate all of facial muscles. So he was really excited to have a male gorilla that was not preserved. This was a big treat for him, and so he was a wonderful part of our team. The Human Evolution exhibit at the Smithsonian opened just a few years ago, and a lot of his work, his sculptures and his reconstructions are really an important part of that exhibit. Well, Bwana was the beginning of the 5 silverback males that we came to study in the ensuing years. One year, I got a call from Oklahoma City Zoo and offered their silverback plus a juvenile female and then 2 babies. Well, the shipment arrived on a Friday. It was a huge container, you can imagine, with all of those animals in it. They were frozen, they had dry ice on them. The elevator was broken. And it wouldn't be fixed until the middle of next week. So here we are with all those frozen animals. But the job of finding a freezer fell to Richard Baldwin. And by some miracle, Richard found another place somewhere on campus. I didn't know if you had to go, you might have had to go downtown, but we found the place. And at the time, I didn't know anything about this because I wasn't on campus. So he located space in another freezer on campus. Now, on the following Monday morning, I received a phone call from a slightly irate biologist on campus demanding to know, what are these gorillas doing in my freezer? But I explained, we smoothed everything over, the gorillas were safe, and in a few days they were moved to social sciences. So our work on Bwana was really engrossing, and some of the interesting things that we discovered about these males is that they had different body proportions from the females. They have really much heavier upper limbs. They have more muscle. The size of their muscles, like deltoid and biceps, any bodybuilder would look completely puny next to these guys. They're just really huge. One of the interesting things about being a silverback is there is a dome that they have on their head. So we were interested in the construction, what was going on underneath that. And so it's a bony crest called the sagittal crest, but it's sort of packed with connective tissue, like packing around it so that it ends up being a smooth, round dome. Well, the results were written up in the alumni magazine with Bwana on the cover, and I just want to show you that. This went out nice, and a story about Bwana, and of course the famous picture that you just saw, that's when this picture was taken, with Bwana's skull. So these were sent, the alumni magazine was sent out. And as it arrived in Seattle, Washington, our UCSC alums read the story about Bwana. And the day, literally almost to the day, the Seattle Zoo announced the death of Congo, their silverback male. So suddenly, all of these phone calls from alumni are coming. Some of them came to me, but some of them went to the chancellor. I mean, these students wanted me to get Congo. And they wanted to make sure that, that I knew about it. And as a result, after a lot of negotiation, I did, in fact, get Congo. Well, he was incredible. He was 450 pounds. He made Bwana look like a little peanut. He was just gigantic. Well, about the time that we started our work on Congo, I received a phone call. You can see now, we didn't have texting and all this kind of stuff. It was the good old telephone. Got a telephone call. Actually, I got 2 telephone calls the first time. However, I should not have been surprised at the marriage of anatomy and art, because the history of anatomy is also a history of artists. Leonardo da Vinci, Michelangelo, Vesalius, along with present-day artists who also render human anatomy, particularly someone that we are recognized as being particularly brilliant, and that is Frank Netter, who did incredible art for SIBA. He was a physician, anatomist, artist, and I have the book. His daughter wrote a biography of him, Medicine's Michelangelo, The Life and Art of Frank Netter. And the thing that's rather touching about this is that when his mother was on her deathbed, she made him promise that he would not try to make a living as an artist. He managed to do it. He managed to do it. Well, I initially undertook this anatomical research to answer functional and evolutionary questions about human origins. But in the intervening decades, it grew into something more by chance than planning. For such unpredictable research, it's very hard to impossible to write a grant when you don't know when your subjects are going to show up. It can be any time. But in the now 40 years that we've been doing dissections here at Santa Cruz, I've dissected over a dozen gorillas, 4 orangutans. I've lost track of gibbons. It must be at least 20 by now, 2 dozen chimpanzees. I mean, just an incredible number. Carol and I keep thinking one of these days we're going to count them all up, but we haven't quite done that yet. And over the years, our dissection teams included a lot of students from UCSC and Cabrillo College students that Robin would bring over from her classes. And of course, Linda, Robin, and Debbie Bolter participating in so many of these dissections. A relatively newcomer is John Hudson, that has been contributing tremendously through his skill as an anatomist and his can-do approach. Nothing phases him, even if it means driving 3 frozen chimpanzees to Santa Cruz from Milwaukee in the dead of winter. About 10 years ago, an undergraduate anthropology major came to me interested in drawing bones and in observing dissections so she could sketch the muscles on the animal. That student, Carol Underwood, I'm going to get emotional. She came to be a passionate anatomist and has an amazing ability to combine the rigors of an anatomist with the intuition and the sensitivity of an artist. So we joined forces to create a book on the comparative anatomy of all the apes, gibbons, orangutans, gorillas, chimpanzees. And our goal is to bring together the data that we have collected over the years, showing the parts relative to the whole and the whole relative to the parts, the similarities and differences among the apes, females and males, infants and adults. The images from watercolor paintings of apes in their habitats, pen and ink drawings, multicolored diagrams, and digital photographs of muscles and bones are visually pleasing as well as being instructive. So you can look at all the pictures and not ever have to read the text. So So our partnership continues the time-honored tradition of pairing anatomy and art, but we also add a scientific and an evolutionary perspective and try to bring the anatomy lesson of Dr. Tolp into the 21st century. Thank you.
Generously agreed to take questions.
I'll just start with that comment, Adrian. I remember when moving into the building that there was some resistance to our having that freight elevator, and we made this argument about, do you really want to see these animals in the elevator with the passengers going up? And we went on about how messy and smelly that might be. That was one of the things that helped us to actually get that freight elevator.
Have to be persistent.
So you started with bipedalism, upright posture, and you talked a lot about the apes that are not bipedal. So where are we in the figuring out what happened?
Well, you know, that's one of the things that we've really learned, because chapter 14 in our book is all about bipedal locomotion. And it turns out all of the apes have the capacity to be bipedal under a lot of circumstances, but their anatomies are all different from each other and from us. And so with emphasis on different muscles, the emphasis on the different length of the limbs, the masses of the limbs, and so that's one of the things that we want to talk about, is all the different ways that you can be bipedal. The other thing that's happening is that there's now quite a lot of fossil material. Fossil stuff is being discovered at a rapid rate, and one of the things that they have found now, foot bones from at least 3 or 4 different, supposedly the same species, but they're all different, and indicate that even 2, 3, 4 million years ago, there were a lot of different experiments in being bipedal, because what we have is maybe as recent as a couple of 100,000 years. But it started shaping up around 2 million years when we start seeing hominids leaving and populating other parts of the earth. So we've got a really refined system, and it works well, and that's why we've been able, you know, when you think about travel, you know, you think about global, you don't think about walking, but our ancestors had to walk. Occasionally take a boat later, but mainly walking, and just think of that.
So I'm wondering what you think the most interesting question in human evolution is right now.
I don't think that I could say it would be just one question.
But because it may be the top 3. Like sort of what, or maybe another way to put this is, if you could imagine solving any mystery, right, in that kind of fantasy way, which one would it be?
I guess that maybe another way to do it, if I could go back 3 million years ago, I'd really like to know how far they walked, how they made a living, how they were organized socially. You know, that's really, it's that transition from apes to humans, and that very early human, because what we see in this early fossil record is all kinds of experiments going on. And it could have gone any number of ways, and there's just more kinds of, they're having a terrible time with all the taxonomy of these fossils, because there's just much more variation than we could even imagine. And that's why this chapter, I'm talking about bipedal, all the different ways that the gibbon does it differently, the orang does it differently, the gorilla and chimp do it differently. They've got different anatomy, but they can get around bipedally. So to kind of think about the variation. So then when you think about that transition, that's what was happening 4 million years ago, was a lot of experiments. Because obviously, this kind of of locomotion gives you a lot of advantages. You can get away, you don't have to be dependent on trees, you can go farther distances, gives you all kinds of possibilities for getting different kinds of food. And so it obviously worked, and that's why the experiments that we see in the fossil record even make it better, make it really effective. So I guess that would be one question, but it entails a whole bunch of questions.
Have you had an opportunity to observe or participate in a dissection of human being at medical school or something like that?
Oh, yes, I took human anatomy, but I also got a human cadaver just that was my personal one. And did the Ted Brand method. So I took it apart. In fact, Linda helped me. I took it apart exactly the way that I've done the apes. And so, as a result, I've got really nice comparative information on a sample of one. But one is better than none. So yeah, but that's not where I'm a little OD'd on human anatomy. It's really all the things that we don't know about the apes. Yes.
Have you found noticeable differences in the hand structure with the species that are more bipedal because they're not relying on their hands on the ground so much?
Yes.
Yeah.
Yes, the gibbon hands, the orang hands, chimp and gorilla hands, they're all different. The chimp and gorilla are fairly similar, but they're all different, and even some different muscles. The gibbon has a really nice muscle that goes to the thumb that's lacking in the gorillas and chimps.
But what percentage of time do they spend bipedal, the gibbons in comparison?
You know, somebody is doing a study in the wild on that, asking that very question.
Thank you.
One more question and then we have something else reading.
You mentioned early that it isn't just the legs that have to do with bipedal, but the whole body.
Right.
And as you were learning this, what surprises did you have about the upper body? You must
Well, yeah, that was part of actually the preparation for my PhD was, and that is how much, what we really are about as bipeds is centers of rotation. And they're all, so our arms, so we have rotation of the shoulders, we have rotation in between our pelvis, we have rotation at our hip, knee, and ankle joints. And if you walk along, you'll